So, um, Alex has requested a video on projectile motion for to study for the final. So I took this question that we did back when we were covering this unit. A basketball player tries to make a half-court jump shot, releasing the ball at the height of the basket. Assuming the ball is launched at 51.0 degrees, 14.0 meters from the basket, what velocity must the player give the ball? So to start with projectile motions, we should always draw a diagram. In this case, usually it's a triangle. So we have VI, then let's label VIY. You need to write the components because you'll be using them for any projectile motion question. Then it says 51.0 degrees is where it's shot at. Okay, so now that we have this, we start, when we're not given VI, that makes the question significantly harder. So we need to make expressions for VIY and VIX in terms of VI. So we have to use the trigonometric ratios. So let's start with sine of 51.0 equals opposite over hypotenuse. So opposite is VIY and hypotenuse is VI. And then we can rearrange this, multiply the VI over and divide the sine 51, or wait, opposite over hypotenuse. Oh, okay, yeah. We're looking for VIY, an expression for VIY. So VIY equals, multiply the VI over, so it's just VI sine 51.0 degrees. Okay, that's our expression for VIY. Now we do the same thing for VIX. So cosine 51.0 equals VIX adjacent over hypotenuse, so that's VIX over VI, and VIX equals VI cosine 51.0. So same thing as the last one except cosine this time. Now, when we're doing projectile motion questions, you have to think of it as two different problems, one for vertical, one for horizontal. So I think I usually start with the vertical. So in this case, when we don't have the VI, we use the formula D equals VIT plus 1 over 2 AT squared. And since we're looking at the vertical, we changed this to dy and VIY. And you can also put AY, but that's just G. So we know that dy, since the ball goes up, okay, let me draw a diagram. It's shot from this here and hits the basket over here, and it says that they're at the same height. So that means the total vertical displacement of the ball is 0 degrees, or 0 meters. So we do 0 equals VIYT. So we take our expression for VIY, VI sine 51.0 1.0, sorry, vi times 51.0 and times t plus 1 over 2 times negative 9.81 meters per second squared times t squared. So now we're looking, by solving this, we're looking for t, because if we have t, then we can put t in terms of solve for t on the vix and the viy, and then the vi variable will cancel out. So I'll show you. We take 1t out, we divide both sides by t, 0 divided by t is 0, equals vi sine 51.0 plus, we can expand this, that would be negative 4.905 meters per second squared times t. Then we just subtract the vi sine 51, then divide by negative 4.905. The negatives will cancel out, so it'll be vi sine 51.0 divided by 4.905 meters per second squared. Okay, so now solving for x, or the vi using vix, when we're doing the x component, we just use the triangle dvt, and then just take one variable and solve using the others. So we're looking for t in this case. T equals d over v, dx over vx, or vix. Dx, that's given to us, 14.0 meters. And vix, we use the expression we made, vi cosine 51.0. Okay, we don't equal anything. So we have t equals 14.0 over vi cosine 51. We also have vi cosine, t equals vi sine 51 divided by 4.905. So we can just go ahead and make these two equal to each other. Divided by vi cosine 51.0 equals vi sine 51.0 divided by 4.905 meters per second squared. So now we can cross multiply, move the vi's both to one side. So we have 14.0 meters times 4.905 meters per second squared, 9, and this is a 5, equals vi squared. The two vi's, we can simplify them to vi squared, and then we have sine 51.0 times cosine 51.0. Then if we isolate vi, we get vi equals square root of 14.0 meters times 4.905 meters per second squared, and divided by sine 51.0 cosine 51.0, and now we just put that all in our calculator. 14 times 4.905 divide by sine 51 divide by cosine 51, then square root that. We get 11.8494, but in this case we round it up to 3 sig figs, so it's 11.8, and the unit is meters per second because we're solving for velocity. But it also says on the question what is the velocity, so we also need to write the angle, which is given to us here. So it's 11.8 meters per second at 51.0, put this in square brackets, degrees, and this is our final answer. Thank you for watching. Let me know if you need another video on projectile motion.